A for loop in LabVIEW is one of the fundamental structures that is frequently used. To get to this tab, right-click, hover over Structures, and click on For Loop. Left-click and drag the box to the size you desire. The main components of a for loop is the loop counter, which we can add by right-clicking and create a control, and also a loop indicator, which we can right-click and create an indicator. A sometimes overlooked part of a for loop is this indicator on the loop counter. If we right click and add an indicator here, we can see if we add, let's say, a 3 and click run, this numeric 3 is passed into the loop. The loop indicator is now a 2. If we highlight execution by clicking on this light bulb, we can see the code run in slow motion. So the 3 will get passed through every single loop cycle. Before we run that, the indicator starts at 0 and then goes up to 2. The loop indicator starts counting from 0. Okay, I built a little example here that a for loop can be used for. I did this by I created a constant, which is just right-clicking numeric and then numeric constant. And then here's also all the math functions that can be used. I just use add for this. So if you click, you see that little spool appear. You can click on the wire and drag through. Oops, hit escape to cancel the move. You click in the loop, then continue this wire to the end. You can right click and you have tunnel options. It's like last value, indexing, concatenating, which is used for strings, and conditional. So in this example, I just have a constant number 1. And then this is the tunnel version, which is a solid block. Then I have this incrementer, which is attached to this this symbol is the array. I have a shift register, and what that does is it takes the value and actually goes around and passes it back to the loop. So similar to like how in C it'd be like I++, that's what a shift register is doing. And then we also have a conditional case, which pretty much you can add some logic to an array to allow an element to be indexed. This can be used for like even and odd numbers if you need to sort, or any other logic example. So if we run this, as we can see, our loop counter is ran 3 times. The 3 was passed through like we spoke before. The loop indicator was 2. The tunnel is 1, which was the original. Our array ends up with all 2's, because 1 plus 1 is obviously 2, and it has 3 elements, and that was our loop count. Our shift register is 4, because 1 plus 1 is 2, it gets passed around. 2 plus 1 is 3, and then so on and so forth until the last number is completed. And then our conditional case, as you can see, nothing appeared. But if we click this to true and we hit run, now our array elements are assigned. This can also be, the loop counter can also be passed through. So we just quickly do a create indicator. Call this loop array. This time let's just run this twice. Grab our loop array. We can click and grow this array as large as we want. We can also go left and right if we want. It doesn't matter on a 1D, one-dimensional array. We hit run. We can see our loop ran. It's 2 times, which is equal 1. So if we put this up to 4, hit run, everything fills in. Thanks for watching. I hope this was helpful.